So nowadays, as we know that our GTU exam will be conducted in MCQ manner. That is why the problems should be important for the MCQ. So we are going to see the problems for the chapter number 5, the laser, sound and optical fibers. So let's see the formula for the chapter number 5, or you can say the unit number 5. So first one is speed of wave. So speed of wave is given by v is equal to lambda into f. Lambda into f is where the lambda is nothing but a wavelength and the f is nothing but a frequency. And the second formula is nothing but you can say that it is a frequency. Frequency, it is nothing but a reciprocal of a periodic time. Now the third formula is given by the power of a lens, that is 1 upon f, where f is a focal length. And the fourth formula is the focal length. The focal length is given by 1 upon f is equal to 1 upon do plus 1 upon di, where do is distance of object and di is image distance. Okay, and the formula number 5 would be given as the refractive index is given by mu is equal to c by v, where c is the speed of light in air and v is the speed of light in a given medium. Okay, formula number 6, that is in optical fiber, numerical aperture is given by Na. Numerical aperture Na is given by under root of n1 square minus n2 square, when n1 it is a refractive index of a core and n2 is the refractive index of a cladding in optical fiber. So these are the formula. Let's begin with the problem number 1. So the problem number 1 says that the speed of a sound in a given air is 30,000 centimeter per second, and if the frequency of the sound is 300 hertz, then calculate the wavelength of sound in water. So we have a given data, that is velocity has been given, that is v is equal to 30,000 centimeter per second. That is we are going to convert it is in a MK system, that is 300 meter per second. The frequency has been given, that is 300 hertz. So as we know that the formula of a speed of wave v is equal to f lambda or a lambda f. So we want to find out the wavelength. So make a lambda. So we can write lambda is equal to, make a lambda as a subject. So lambda is equal to v upon f. So as we know that the v is 300 divided by 300. So it will be cancelled out. So lambda is equal to 1 meter. So this is this kind of examples should be asked in your examinations. In this examination, in this example, you can you should be given you will be given any two kind of parameters, and the third one should be find out by you. So next let's see the example number 2. So an object is placed at the distance of 15 centimeter. So distance of object distance is given by 15 centimeter, as well as the image from the convex lens is formed at the distance of 30 centimeter. So distance of image is given by 30 centimeter. We want to find out focal length and the power of a lens. As we know that the focal length, that is 1 upon f is equal to 1 upon d naught plus 1 upon di. So that is given by 1 upon 15 plus 1 upon 30. So just calculation do it, take a LCM as a 30. So 2 plus 1 divided by 30. So make f as a subject, so 30 should be in a numerator and the 3 would be the denominator. So your answer for the focal length, that is 10 centimeter. And another one is we want to find out the power of a lens. The power of a lens should be given by P is equal to 1 upon f. So we have already find out the value of f. The focal length is given by 1 upon 10. So 1 upon 10 is not, it is nothing but a 0.1 diopter. So the power of a lens should be 0.1 centimeter inverse, or you can say the diopter. Okay. So this kind of a problem should be asked in the MCQ and GQ examination. So let's see again the problem number 3. The refractive index of a glass is given by 1.5. If the speed of a length in a vacuum is 3 into 10 raised to 8 meter per second, then find out the velocity of light in a medium. So refractive index is given by mu is equal to C upon V. So, and in this example, mu is given by 1.5, C is given by 3 into 10 raised to 8 meter per second. So we want to find out the velocity of light. So make a subject as a V. So V is given by C by mu. So C is 3 into 10 raised to 8 divided by 1.5. 1.5 multiplied by 2, that is 3. So cancel out. So 2. So again the velocity of a light in a medium is given by 2 into 10 raised to 8 meter per second. Let's see the problem number 4. So problem number 4 says that the refractive indices of a core and the cladding materials of a step index fiber are given by 1.4 and 1.48 and 1.45. Then calculate the numerical aperture. As we know that the numerical aperture is given by under root of n1 square minus n2 square, where n1 is given by 1.48 and n2 is given by 1.45. So just put the value of n1 and n2, just square it and take a square root of both of them. So numerical aperture is given by 0.2965.